Okay. So, technology, be my friend. Thank you. Okay. So again, it's not the most important thing in the world, but it does help you guys follow along when we're talking about things like that, especially when it comes to looking at how to read instruments, right? We'll often refer to an instrument as being precise to the tenths place or the hundredths place, something like that. So just being able to identify that language will be helpful for you. Does that make sense? Any questions about place values? We okay with it? Coolsies. All right. So the next thing we want to talk about nope. So I'm going to do just like a brief overview of adding, subtracting with positive and negatives. So again, maybe very basic, but just want to make sure everybody's on the same page. So when you add a positive and a negative, right? It's basically just like you're taking that first number and subtracting the second number, right? If you have two negative numbers that you're adding together, then you're adding the negatives, right? So you'll end up with a negative value. Let's just look at some examples because I think that makes it easier to think about. So let's say I have 3 minus 8, right? We don't usually write the plus there, but it's implied. So what would that give me, guys?
-5.
-5, exactly, right? But let's say we have -5 minus 10.
Five.
That one's going to be +5, right? So when you have a negative and another negative next to each other, they're going to give you a positive value, right? So this guy reduces to +10, which gives us +5 here, right? Everybody still all right with me?
Yes.
Cool. That's about as much as you probably need to know. I just like to refresh everybody on these things because these are the areas where I see common mistakes happen. Oh, calculators. So if you guys don't have your calculators yet, that's fine. But ideally by Monday, if you can get your scientific calculator, you really want to stick with one calculator for the entire semester because that's going to, because learning how to use a scientific calculator can be kind of a learning curve. And so I'll be showing you how to use some of the calculator functions on my calculator, which is the one that I put in the announcement. There's different colors too, you don't have to get pink, but that's the one that I'll probably be doing examples with for you guys. And then let's talk about fractions.
Professor?
Yes.
Are you going to be recording your lectures and then posting them on your YouTube, or?
You are currently being recorded, my friend.
Oh, okay.
So yes is the answer. Cool. So fractions, also known as ratios, okay? I'll kind of use these two terms interchangeably, all right? So to me, they mean the same thing. Occasionally, I'll do a whoopsie-daisy and I'll call a percentage and a fraction basically the same thing. I realize that that's not technically true, but the only difference between a fraction and a percentage is what? So if you want to go from a fraction to a percentage, what do you need to do?
Percentage has a 100 in the what do you call it? Lower section? I don't remember the name.
Denominator.
In the numerator.
Thank you.
Yeah. So let's say you have a decimal, right? Times 100. That's what gives you a percentage, right? Is everybody with me? We're okay? Cool. So to me, these three things, sorry, scooch it, are basically the same, right? Because a fraction can be reduced to a decimal, right? And a ratio is just a fancy $25 word for a fraction, right? I don't know which one's fancier, but they're the same thing, right? So just be aware of the fact that the way that I'll be using that language, these guys are all basically interchangeable, okay? So let's do fractions. I know everybody loves them. So I'm never going to be asking you for incomplete, or is that what they're called? Incomplete fractions? Reduced fractions? Basically, I don't ever want to see fractions in your answers. I always want you to answer in decimal form, okay? Does that make sense, guys? Coolsies? Cool.
Makes sense, but is there a part you'd like us say to stop at? Like if we get past the thousandths with our answer?
So,
But like repeating if it's something like that?
we're going to get to that when we talk about scientific notation. Yeah. So the short answer is probably 2 decimals, maybe 3. But yeah, does that make sense? We'll get there. So if I have 1 divided by 4, you guys know this one?
0.25.
Yep. 0.25, right? So why do I say fractions and decimals are basically the same thing? Because they are, right? They're equivalent to each other. So 1/4 of something is 0.25 of something is 25% of something, right? So if I took this and I multiplied it by 100, right? Now I have 25%. Does that make sense, guys? So that's why I kind of use these terms interchangeably. But I don't want you to be confused by them, right? So I want you to know what the heck we're talking about. And I know that especially for people who haven't taken math in a long time, fractions can be something that give people a lot of anxiety, and I get that. So if you're not following, especially at the beginning of the semester, please don't hesitate to let me know. I'm happy to go through things again, okay? Questions about fractions? Cool. So I think this is a relatively easy example, right? If we looked at something that, I don't know, let's say looked a little bit more complicated, something like this, right? I don't know about y'all, but I'm probably not going to be able to do that in my head. I'd need to put that into a calculator. But you could do it, right? It would still just give you a number. Can anybody give me what that number equals? Anybody got a calculator handy? I know y'all got your phones.
63.67857143.
I'm doing that. Can you guys still see my screen? Yeah, we cool? Cool. Sometimes I'll go off the board, so just let me know, because I have multiple screens open at once, so I can't see my entire screen, so just be aware of that. Right, so again, not super complicated, but this is one that you probably want to have a calculator for, but we can do it, right? Again, this would be what I would want you to answer in. I don't want you to try and figure out if there's a fractional form of this that this reduces to. That's horrible. We're not ever going to do that, okay? Questions about fractions. Fractions and ratios. Cool. So the one other thing when we talk about fractions and ratios, I think this kind of problem is hopefully pretty familiar for you guys. It's just division, right? But when we're talking about units, which just about everything that we talk about in chemistry is going to have units, I think that's when people get a little bit confused about ratios, okay? So let's say we have something like this, right? So I have 25 grams divided by 25 milliliters. 25
1 gram. I'm sorry.
No, that's great. So 25 divided by 25, they cancel each other out, right? Everybody's comfortable with that? So my coefficient, the number that I get out here, would be 1. Everybody's cool with that? Cool.
Yeah.
But my units here are still going to be a ratio. Does that make sense?
Yeah.
Yes.
So because grams can't cancel with milliliters, they're not the same unit, I have to keep both of them
Grams
in
per milliliter, which is, I think, a unit of density.
It is a unit of density. Yeah, excellent. So, and we'll talk much more about units. But yeah, so that's what we're saying here, right? If you have two units that are different, you can't just pick one. And I know that that sounds silly to some of you, but this is easily the number one mistake that I see students making early on. Especially like this number divided by the other one was pretty straightforward. It was easy for you to do in your head, but the more complicated these coefficients get, the easier it is to just forget about the units afterwards, right? So one of the things that we have to really practice in this class is being very attentive to units, okay? Questions about how we did that? Cool. So another thing that we can do with units, let's say we have 3 centimeters times 2 centimeters, right? The 3 multiplies times the 2, and that gives us
6 centimeters.
6 square centimeters.
So you'll have 6 for the coefficient, right? But the centimeters also multiply together, right? So you'll end up with centimeters times centimeters, right? Which is centimeters squared.
Square centimeters.
Exactly, Juan Carlos, sorry. Your name on the screen is just Juan, so I'm always gonna forget.
It's okay. Call me whatever you want.
All right. Does that make sense, guys? So in the same way that coefficients are going to be multiplicative, right? Their units are also multiplicative, right? So if we have, oops, I'm going off the screen here, guys, sorry. If we have length times length, which hopefully you guys are okay with me on that, right? Centimeters, inches, feet, right? Those would all be units of length. So if I have length times length, then what does that give me in terms of units?
Area.
It gives me area, exactly. Oops. Does that make sense, guys? So, again, if this is uncomfortable for you, that's okay. We're going to have a lot of practice with it. Your entire first homework from chapter 1 is going to be all math review. So, I know. Huzzah! Right? And there was much rejoicing. Questions about that? Cool. By the same token that we can multiply these units together, right, we can also divide and cancel units if they're the same, right? So let's say I have centimeters cubed divided by centimeters, right? You could put a 1 out front if it makes you happier. So this is a unit of length, right? But what is this a unit of?
Volume.
Volume, exactly, William. So here we have a volume divided by length, right? And when we do that out, that's going to give us an area, right? So we have this centimeters cubed is equivalent to centimeters times centimeters times centimeters, right? They mean the same thing. So what I can do is take one of the centimeters from the bottom and cancel with one of the centimeters on the top. Now I just have centimeters times centimeters, aka centimeters squared. Everybody cool with me? Yeah, Brianna, what's up?
Might be a silly question.
Not at all.
Excuse me. So length is the regular centimeters, squared is area. If it's cubed, is it gonna be volume
Yes.
each time, or?
Yes, always.
Okay. I'm just
And-
trying to
Yeah,
catch and
we're gonna
each
talk
different-
more about units in detail towards the end of the class. I just wanted to kind of introduce those concepts as we go. So we'll talk more about
Yeah, I
it.
just want to get understanding that. Thank you.
Absolutely, totally. Any other questions on what we've gone over so far? How are we feeling with this stuff, guys? Relatively confident, hopefully? Cool.
Unless you practice and you feel better.
Yeah, so that's the other thing is I just assume that, most of you guys haven't seen this for, I don't know if you're my age, maybe it's been 10 years, 20 years, I don't know. So I just come to the table assuming, that it's been a long time and that you guys need some refreshing on this. So I apologize if this is really rudimentary. Then that'll be a really easy chapter for you. Cool. All right. Is it okay if I erase, guys? We're good? Cool. By the by, if you're not taking notes, you're doing yourself a disservice. Part of the way that our brain learns is by writing things down. So one of the ways that we learn is by hearing, so audio. One of them is by reading, and one of them is by writing things. The last one is by teaching. So when you're working with each other in groups, you're really helping each other. You're really helping yourself learn, right? So I encourage you guys definitely take notes while we're going through this. Okay, so let's talk a little bit about algebraic equations. Oh yeah, cool. Everybody's favorite. So this would be something like x plus 3 equals 7, right? So any kind of algebraic equation is just a fancy way of saying we're trying to solve for a variable, right? Now, I don't know about you guys, but when I took algebra for the millionth time, I'm not exaggerating, I literally took it 5 times, I was like, what the a variable? Why? What? Who is this variable? I do not care about it. And that's really completely understandable in a math context, but thankfully, mercifully, in a chemistry context, we always have a meaningful variable, right? So usually when we're talking about a variable, we're actually talking about a quantity, something that we're trying to solve for. So I think hopefully, getting rid of the x and putting in actual things that we're looking for will be helpful for you guys in terms of understanding the algebra here. But let's just talk about the mechanics here. So if we have x plus 3 equals 7, right? We want to get x by itself, right? So how can we get x by itself?
Subtract 3 from both sides.
Yep, so we want to subtract 3, right? Whatever we do to one side of the equation, we have to also we have to also do to the other side of the equation, right? So we subtract 3 here, that gets rid of the 3. Here, that'll give us 4, right? So now we know that x is equal to 4. Does that make sense, guys? Cool.
Yes.
Let's say we have x divided by 36 is equal to 100, right? So how would we get this x by itself?
Multiply 36.
No.
Yeah, so we do the opposite operation in all cases, right? So the opposite operation of addition is subtraction, right? The opposite operation for division is multiplication, right? So we can multiply by 36 here and by 36 here. This guy cancels with this guy, and now we have x is equal to 3600. Okay. I'm not able to look at the chat right now, so if you guys have questions, if you can shout them out, or if you see anybody in the chat has a question you want to point it out to me, that'd be awesome. So, if we have 4x is equal to 13, how would we get x by itself then?
Divided by 4 on each side.
Yeah, so in the same way that multiplication will undo division, division will undo multiplication, right? So we divide by 4, we divide by 4, and we end up getting x's of 3.25.
25.
Yeah. If y'all can do that in your head, that's okay. That's what calculators are for. So you'll always have a calculator on an exam or a quiz, all right? There'll never be a time when you have to figure that out in your head. I've just done enough of these that my brain works like a high-functioning person on the spectrum. So yeah, anyways. Questions about those? You guys feeling all right with that?
I actually have a question.
Yeah, please.
My camera's not on because I'm at work, sorry.
Cool, that's fine.
If the decimal was like longer, let's say it was like 3.2555555, what would you want us to round to? Tenths?
So that was the question that I think Brianna was asking earlier, and the answer is we're probably always going to have 2 decimal places because
Two decimals, okay.
Excuse me. Because we're going to put our answers often in scientific notation. And so when we start talking about scientific notation, we'll talk about how many decimals you usually want to carry. Occasionally there'll be an exception to that where I might ask you to give me more than 2 decimal places. Excuse me. I usually lose my voice the first week. But I'll always be explicit about that, right? So you can kind of default to 2 decimal places. That's probably a good guess.
Got it, thank you.
Yep. Any other questions so far? Doing good. Awesome.
Actually, I do have a question.
Go ahead,
which
Miles.
is, in the Chem lab,
Yes.
I had a little quiz or something like that for math review, going over all of this stuff.
Yep.
Is that the homework that you were referring to, or do we have more homework for Chemistry 100?
So the Chemistry 100 homework is going to be, there's homework for each chapter. Each module has, I think it's whatever the 0.4 section is going to be the homework section. So for the homework for this chapter, chapter 1, which is what we're starting right now, there is math review involved. Yes. There's more than just that. We're going to go into problem solving as well. But yeah.
Yes. Sorry, I maybe I was being unclear. I was wondering if I already did the homework.
You did not.
Like, would it have been posted under lab?
No, that's what I'm saying. Those classes are completely separate.
Both.
Yes, there's 2 places where you have to practice this information. Yeah.
Okay.
Yeah. So, and again, I apologize if this is very easy for you, then hopefully it will take you no time at all. But I find that if students have barriers, we got to get them out of the way ASAP to make sure that that they understand the problem solving stuff, right? So we gotta get some basics down. So any other questions about what we got going on here? Cool. So can I erase? You guys all right with that?
Yeah, go ahead.
Cool.
Someone in the chat did just ask how you got the 13 over 4, though. I don't know.
Oh, so when you divide both sides by 4, right? Oops, sorry guys. Yep. The 4's cancel out, right? But you're left with 13 over 4. Does that help? Cool. We'll talk more about it on the side if you want. Okay, so I think generally people tend to be, quasi-comfortable with that. There's a couple of instances where I think people get a little bit tripped up with algebra, and one of those is when you're working with a variable, in the denominator. And the other one is when you have an equation that is all variables. Okay, so what the heck am I talking about? Let's say we were talking about this equation. Anybody familiar with this equation?
It's on the review.
It is on the review.
Density.
It's density, right? D stands for density, M stands for mass, and V stands for volume, okay? So this is a really common type of calculation that you'll be working with in lab and in lecture. So let's say we were asked to solve for volume, right? Solve for V.
You multiply B on both sides.
That's exactly right. So you would want to multiply V here to cancel it out, and also multiply V, oops, just kidding, that doesn't cancel, over here, right? So what that reduces to is volume times density is equal to mass, right?
I have a tip for the equations with variables. The way I learned it was PEMDAS, PEMDAS. I don't know if you're going to talk about that, but I find that really helpful.
Yeah, we talk about that in lab too. So PEMDAS is talking about the order of operation, right? So we haven't really gotten into anything that's complicated enough to talk about order of operation, but that's on our list, right? So this is parentheses, I can't spell, you guys.
Just draw them.
There you go. That's a better idea. Those guys. This is exponents. This is a good news for anybody else that's really bad at spelling. Just become a scientist. Nobody cares. Not an English major. Who cares? This is multiplication. Multiplication. Blah 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 blah. and division, addition, and subtraction, right? So this is just talking about the order of operations. And we'll talk about this when we get into some slightly more complicated guys. Questions about the variables in the denominator and equations that are all variables. I think the equations that are all variables, as long as you think about the problem in terms of what you're solving for only, right? It doesn't really matter what everybody else is until you've got this. Oh wait, we didn't finish that. Sorry guys, we started talking about PEMDAS. So we were still trying to solve for volume, right? So do we have volume by itself?
No, not yet.
Nah, right? Thank you. Sorry, guys. It's clearly 8 o'clock in the morning. So what can we do to get V by itself?
Divide by D.
Mm-hmm. Divide by D. Divide by D. Right? So we have V is equal to M over D. Making sure that you do both of those steps is super important to being able to get an answer that's actually a volume. So we're talking about this just for the algebra so that you're comfortable with the algebraic expressions. But what we're going to talk about later on, probably on Monday, is problem solving techniques. So we have this beautiful thing called dimensional analysis in chemistry, where we look at the units, and whatever units we want to end up in, those are the units that we solve for, right? So eventually I'm going to tell you to just never ever ever do this again. And the reason being because we'll have a technique that you can always use no matter what, whether it's density, whether it's literally any kind of conversion that you want to do. So so for now, I just want to make sure you guys understand how to do the algebra here, but eventually I'm going to tell you don't ever use D equals M over V. So beep bop beep boop, we talked about that. Okay, so let's talk about scientific notation. Which I will probably from now on refer to as Sino, because I'm lazy and I don't like writing that on. So scientific notation is basically when you have a really large number or a really small number, it becomes really difficult to conceptualize the magnitude of that number, okay? That was a lot of fancy words for saying it's just really crazy big and it's hard to think about, right? So let's think about a number like this. Yeah. I don't know about you guys, but just looking at that number kind of hurts my head, and I have no idea what it means, right? One of the ways that we help ourselves think about the magnitude is by putting commas in here, right? But even that doesn't really help me. So scientific notation is going to take this number and separate it into two components. We'll have a coefficient and a power of 10, or 10 to some power, right? Okay, so how do we get there? So there's an invisible decimal place out here, and in order to put this into scientific notation, I need to move the decimal place over until I get one non-zero digit out front, Okay, everybody all right with me on that? So I would go 1, 2, 3, 4, 5, 6, 7, 8. Right? So now I can rewrite this without all those zeros. And I write, so this would be my coefficient. And then I would have my power of 10, because I had to move over 8 times, right? 1, 2, 3, 4, 5, 6, 7, 8. My exponent on the power of 10 is 8. Everybody all right with me on that?
Yeah.
Kind of, sort of? Cool. So I think the place that most students get it... Question? No. Cool. Cool. So the place where I think a lot of students...
Already saw it.
Alright, I'm going to go ahead and mute y'all here. Boop. Cool. So the place where I think a lot of students get tripped up with this is this a positive exponent or a negative exponent? Okay? Especially when you're starting out with the exponent and then you're going to the number. Okay? So the way that I think about this is positive exponents.
You're going off the board a little bit.
Oops, sorry. Thank you. Are big old numbers, right? So positive, big number, okay? Negative exponents are teeny, 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 tiny, right? So small. So negative, small, positive, big. Does that make sense, guys? Cool. And I know this may sound stupid, but I'll literally write that down on the page just so that I can't mess it up. So, yeah, don't be afraid to just write things down. So you don't have to think about them, you just do it. Questions about that? So let's look at an example of something with a negative exponent. Is it okay if I erase, guys? Cool?
Yeah.
So let's say we have a number like this, right? So now we're doing the exact same operation, but we're going to be moving the decimal place in the other direction. So now we're moving to the left. 1, 2, 3, 4, 5, 6, 7, until we get one non-zero digit out front, right? So I'll have 2.2 will be my coefficient times 10 to the negative 7th, right? Again, how do I know that it's a negative exponent? Because this is a crazy small number. Crazy small numbers always have a negative exponent, okay? So when the zeros are out front, usually it's going to be negative, right? Zeros are out back, positive. Questions about that? We're okay. You guys want to do the other way? Going from the sino and taking it out? Just do one? Okay, let's just do one. How about, let's do this guy. So how would we take that out of scientific notation?
Move the decimal to the left.
To the left, yes, I like it. So we would want to move this decimal over 1, 2, 3, 4 times.
4 times.
Yep, you got it, Daniela. So we'll have to fill in 3 zeros here, right? And 1 zero out front. You don't have to put the 0 up front, but I like to do it. So when we rewrite the number, it would be 0, 0, 0, 6, 4, 5, right? So these two numbers are equivalent, right? Is everybody comfortable with that? Cool. They mean exactly the same thing. Now, here's where I think students will get a little tripped up. These two numbers mean the same thing. I'm going to write a couple more numbers that also mean exactly the same thing, all right? So let's say that I had that number, right? Can you guys still see that all three of those numbers are the same number? Right? So this number is still written in scientific notation, but it's not proper scientific notation. So this is an example of proper scientific notation. Okay? Generally speaking, when we're answering questions in quizzes and exams, I'm usually just going to ask you to write things in proper scientific notation. If you gave me an answer that wasn't in proper scientific notation and I didn't explicitly ask for it, I wouldn't mark you off. It might automatically because, you know, it's in Canvas and it's an automatic thing. But I would definitely give you full points for that, right? Because to me, this number, and this number are all the same number, right? So however you want to write them doesn't really matter. For the first quiz, though, just letting you know, because I want to get you guys familiar with proper scientific notation, all of the questions that I ask about scientific notation will be asking you to answer in proper scientific notation. So just be aware of that.
That number is not proper because there's a 0 in front of the decimal.
That's correct, yes. So proper scientific notation, thank you for clarifying that. So proper scientific notation has one non-zero digit out front of the decimal place, right? And then in terms of getting an answer in a calculator that gives you 1,000,000 decimals, right? Usually when I say proper scientific notation, I'm usually asking you for 1 digit out front and 2 digits behind the decimal, right? So usually we'll be talking about 2 decimal places. Just to bring it up, and we'll talk a little bit about it on Monday, there is this wonderful thing in chemistry called significant figures. And it is usually the most painful / hated thing that students have to incur in chemistry. I think it causes a lot of the chemistry trauma that ends up coming through with the students that I see. I don't think that it's particularly important for our level of chemistry. So I'm going to talk about it in the next lecture, and then you'll see it in lab a little bit, and that's it, right? So as far as I'm concerned, knowing how to do rules about which decimal places are good and which are bad, or which you should keep and which you shouldn't, is really something that you need to know if you're working in a lab. But if you're not working in a lab, it's not super important, right? So my goal is to make sure that you guys understand how to do the problem solving more than anything. Okay. Questions? Questions about scientific notation or Coolio? I'm sorry, I say that a lot. I pull out of these verbal hiccups, and now they're on the internet forever. Okay, cool. I'm gonna erase. So, one last thing that I want to talk about in terms of the math review. And we will come back to this at the very end of the semester, and that is logarithms. I don't know why I just blanked on how to spell that word, but I think I nailed it. Cool. You know, sometimes when you write a word and it just looks weird, you're just like, is that right? I'm the only one. It's okay. Cool.
I totally know what you mean.
Cool. Okay, so logarithms, we don't have to do a whole bunch with them, but in our very last chapter, when we get into acids and bases, we are going to deal with logarithms. So logarithms, when we take the logarithm of something, what we're essentially doing is looking at the order of magnitude of the number. Okay, now maybe some of you guys are like, I don't have any idea what the hell you just said, and that's okay. We're going to talk about it. So log is how we represent the logarithm, and we put whatever number we want to take a logarithm of in parentheses next to it. So let's say I have 1 times 10 to the negative 9th, and I want to take the log of that. Anytime you take the log of a number, if the coefficient here is just 1, then whatever your power of 10 is, that's what your answer is going to be, right? So anybody have a calculator handy? Can you go ahead and put this into your calculator? If you don't know how to put scientific notation in your calculator, we're going to talk about it on Monday, so don't stress.
I got -9 is my calculator.
Yep, -9, right? So again, the exponent here is the answer when there's no, when there's a when the coefficient out front is only 1, then you just end up with the exponent, right? When the number out front here is a little more complicated, it's kind of harder to see that taking the logarithm of something gives you the order of magnitude, but that's essentially what they're talking about. Is everybody comfortable with what I mean when I say the order of magnitude?
Could you explain that in a little more detail?
Yeah, no problem. So order of magnitude is essentially just a fancy way of saying the power of 10, right? So whatever power of 10 you have here, right, that's your order of magnitude. Does that help, Troy?
Yes,
Cool.
definitely. Thank you.
Cool. Anyone else? Questions about what we're talking about here?
Can you do an example, please, where you have a different coefficient?
Yeah, absolutely. So somebody do that one for me. So if somebody does this for me in the calculator, what I'm going to walk you through here is I know that the number that I get is going to be negative because my coefficient, or because my exponent here is negative. I also know that it's going to be around 9. It's probably going to be 8 something because it's going to be a little bit less than 9. Anybody got an answer for me?
I got -8.60.
Does that make sense, guys? Kind of tracking with me?
That doesn't really make sense to me.
Mm-hmm.
Why,
Okay.
like, yeah.
So
So
when we talk about powers of 10, right? I think when there's a coefficient of 1 out front, it makes it really easy to see the power of 10 is just a whole number, right? But when you have a coefficient that's non-1 out front, then it's going to be somewhat less or somewhat more, depending on whether this is a positive or a negative sign, okay?
Would it be possible for you to kind of break down the math of that?
Oh, that's beyond the scope of what we need to know. This is basically what I'm going to tell you for that. The explanation of logarithms is something that it took me a long time to understand. And I still don't know that I'm great at explaining it in a math context. But the basic idea here is, how can I put this in a way that's maybe a little more intelligible?
Would it be safe to say when you have the exponent as 1, then the log and the power of 10 cancel each other out?
Yeah, so basically, logs are generally base 10, and a log base 10 will essentially undo the power of 10, right? So if I take the log of 10 to the negative 7th, right? Oops, sorry. What am I going to get? Negative 7. Negative 7, right? This guy is going to come out front. Because the log and the power of 10 undo each other, right?
Could you do this on a calculator?
Yes, I will show you on Monday. Yeah.
Okay.
I'm just assuming that most people don't have a calculator yet, so I want to wait until we have that.
And then okay.
Yeah. So we'll talk more about it, Sadie. We'll get into it again. Questions about this so far? So I would say that understanding logarithms may be more than what you need to know for this class. Realistically, what you need to be able to do is put them in your calculator, right? And that's what we're going to talk about on Monday. Okay? Questions?
And then for the answer, would we be okay to just leave it as like negative 8.6, just because we're assuming that there's zeros at the end?
Mm-hmm. Totes.
Okay.
Yeah. Mm-hmm. Yeah, so I'm pretty generous with the rounding. The only thing that I'll tell you guys is on a quiz or a test, I have to put in a particular answer to have it be marked right or wrong. So again, there may be instances where it marks you wrong, so you'll see like an X next to it, but I've given you full points for that problem, so just be aware of the fact that I'm never going to mark you off for that, but it may look like you got it wrong, if that makes sense. Yeah? Other questions about logs? We cool? Rock and roll. Okay, and again, we'll go over logs again when we get to chapter 10, which is acids and bases. Okay. Thank you. Okay, so the last thing that we want to go over today is units. Okay. Again, I think that the combination of units and mathy things tends to kind of stress people out because it's not something that you do in math very often. But hopefully you'll find that using units is actually a nice way to keep track of things in problem solving. So hopefully I'll get you on board. So we're going to talk more about problem solving on Monday, but for today I just want to talk about the different flavors of units. Cool. So we have, we talked about one already, or two already. Talked about length, right? We talked about volume. And what are some of the other ones that you guys can think of?
Area.
Area, yep. We won't really deal with that one, but definitely.
Mass.
Mass, mm-hmm.
Density.
Temperature.
Temperature. And density, absolutely. Whoops.
Acidity or pH value?
No, that's
no,
actually
that's not a unit. Is
not
it?
not a type
Can
of
it be
unit.
calculated?
It's actually a logarithmic quantity, which we don't consider to be a unit. They're unitless.
Okay.
So I know it's kind of a weird thing, but I'm trying to think if I missed anything. I think for now that ought to say again.
Time or speed?
Yes, time, thank you. So time and speed, velocity, rate, whatever you want to call it, those are all the same thing. They all mean the same thing anyways. So these are all the basic flavors or types of units that we can have, right? But they aren't giving you a specific unit, okay? So now we know the types of unit. Let's talk about a couple of examples of each type. So we gave, in the previous problem, we had the example of centimeters, right? What would be another example of a length unit?
Meter.
Meters.
Millimeter.
Millimeters. Carlos is giving me all the metric guys.
I'm not going to say anything imperial.
I hate the stupid American units is what I will always call them. But we have them, and it's the ones that most people are used to. So inches, feet.
Millimeters?
Millimeters, we got millimeters. Miles. Yards, stupid yards. What do they abbreviate that, yards? Is that?
Yeah, is that? I think that's right. Or is it white D? I don't know. You look right.
I think it's white D.
Whatever. But anyways, you guys get the point, right? So these would all be units of length. Everybody all right with me on that? Cool. Now, this may seem totally random and unnecessary, but when we're doing problem solving, a lot of the things that people get tripped up on are being able to convert between language words, so like written words, and the numerical or variable equivalents, right? So when something tells you to solve for a length, right, this is the kind of unit that you want to be looking for, right? So I really heavily emphasize this at the beginning of the course because the problem solving that we're doing pretty much exclusively relies on you knowing what type of unit a length looks like, or a volume, or an area, or a mass, right? And if you don't know, say, little g grams is a mass, then you're really going to struggle with the problem solving, right? So I'm going to really pound that into your heads at the beginning here. Everybody okay with the units of length? We're cool with that? How about volume?
Cubic is centimeters.
Yeah, we did one earlier. That was cubic centimeters. Sorry, this is getting ugly. I can be cuter. I don't know if that's cuter. Apparently I can't do cuter.
Would cubic milliliters be one?
Totally. Yeah, any cubic unit is a volume.
Liters?
Liters would be our other one, which is Daddy L.
Cubic feet.
Cubic feet. Ugly, but we can do it. Yep. How about cups, quarts, right?
Gallons,
Any
yeah.
gallons?
Gallons kind of
Yeah.
are.
Yeah.
I don't
So
like gallons.
again, getting into those stupid American units, they're a huge pain. BT dubs, the thing that you're going to want to know, I'm sure, is whether or not you need to know all of those conversion factors, and the answer is absolutely not. Going between American units and metric units, I will never ask you to know those conversions, but I will talk about on Monday when we get into the metric system, the required, there's a few conversion factors that I want you to have memorized, just because they come up so frequently. We'll talk about that on Monday.
Is the liters not cubed in the volume?
It is not cubed, right? Because this is a volume by itself, right? Now, there's something a little tricky here, and we'll get into this when we start doing more problem solving, but there is a relationship between liters and a cubic value, right? So 1 milliliter is equal to 1 centimeter cubed, okay? So these guys are related, right? But sometimes we'll have a unit that that's kind of a placeholder, if that makes sense, for another unit, just because it's a convenience thing. Because we use volumes so much, we have a whole nother unit that we use for it. And this is true in a lot of areas. So I think a lot of you guys are going into medical areas. Have you ever seen this before?
Yes.
Yeah, so cc's is essentially the same thing as saying cubic centimeters, right? That's what cc means. Yeah. Light bulb for the day, right? This is your bar trivia for the for a Wednesday morning. Cool. Other questions, guys? All right, I'm not going to talk about area because we don't really deal with that very much. Let's talk about mass, right? So I think we mentioned one, which is grams.
Pounds.
Hmm?
Pounds? Milligrams.
So this is a common misconception, but pounds is actually, lbs is actually a force.
Kilo.
Not a mass, right? So the equivalent metric unit to lbs would be newtons. If you've never taken physics, you have no idea what I'm talking about, that's totally fine. But the stupid American unit for mass is actually a thing called slugs. That's seriously, that's the name. That's what it's called. So
Kilo.
kilograms. Yep. Milligrams, I think somebody said too, right?
Milligrams.
So those would all be units of mass, right? Temperature, we will never work with Fahrenheit because stupid American unit. We will always work with degrees Celsius and
Kelvins.
Kelvin, exactly, right. And I have all of these are listed much more articulately in the chapter 1 key definitions and terms that you need to know. So if you're like, I don't know what K stands for, Kelvin is in the notes, so don't stress out too much. We'll talk more about it when we start doing problem solving with that. So density. So density is always a ratio of mass divided by volume. The most common one that you'll see is grams per milliliter or grams per centimeter cubed. Okay, but there are other ones. California's on fire.
Per square inch.
Cool, yeah, no, thank you. We're not going to talk about it. No, thank you. Yeah, that's another one, but time, I think you guys are all familiar with these, right? The main thing is remembering abbreviations. So HR is hours. S, sometimes SEC would be seconds, right? You guys all know these. Hopefully.
Just a heads up, you're going off the
Thank
board.
you. Thanks. So I think you guys are pretty familiar with these units, hopefully, right?
Yeah.
Cool. And then we won't really deal with speeds or rates, but this is another unit ratio, and this will have distance divided by time. So something like meters per second, miles per hour, right? Something like that. It's always a length per some time, right? Just in the last few seconds that we have here, I just want to mention it's also important that you guys are comfortable with the verbalization of these ratios, right? So when we say length per, the per is the divided by symbol. Is everybody okay with me on that? So this guy means per. Am I off the page or am I okay? We cool? Excellent. All right. I'm gonna go ahead. Oof.